Hello everyone, today let's solve the problem number 62, 62 unique paths. So what the question states here, we are given an m into n grid here, you can clearly see we are given an m into n grid and a robo starts at the left top corner. Here you can clearly see left top corner means 0, 0, right? A robo starts from 0, 0 or the top left corner. This we have to keep in mind, and we have been given an m into n grid. So what is our main goal here? Our main goal is to reach the bottom right corner. Bottom right corner here they have mentioned grid here, right? So we have to reach the bottom right corner. Nothing but this will be in this case m minus 1 n minus 1, right? So this is the bottom right corner. So robo is starting from 0, 0 and we have to reach the robo has to reach the bottom right corner, nothing but m minus 1 and n minus 1 here. The robo can only move right or down. A robo can move right or a robo can move down, right? Down at any step. So we need to determine the total number of unique paths the robo can take to reach its destination. So we need to determine the total number of unique paths that the robo can take to reach the destination. Destination is nothing but this one, the final one, right? This one, finish. No, they have given finish here, the destination one. So I hope this is completely clear, right? So the first part, I hope the question is completely clear here. They have given m equals 3 here and n equals 7. M in this case will be row, n is nothing but the column. Just keep this in mind. We have 3 rows and 7 columns here. The output is 28 here. So the robo can, this one, the robo can reach the bottom right corner in 28 ways, right? So we have to determine the total number of unique paths here. The total number of unique paths the robo can take to reach its destination, final destination, or the finale destination here as 28. You can consider. Same goes with example 2 as well, right? So I hope the question is completely clear. What we will do, let's discuss the approach first, followed by the edge cases one by one, then finally write the code. So here you can ignore the edge cases because we have already seen the example one, right? So we are just given the number of rows and columns here, and here the second example also. You can just go through this one. This completely, this itself we can consider for the edge cases. So let's ignore the edge cases. So let's discuss the approach step by step, and then finally write the code and discuss the complexities of the code that we have written. Initially, let's discuss the here. The first thing that we have to keep in mind here is we will be going with the dynamic programming. So this one we have to keep in mind. We'll be going with the approach dynamic programming, or the DP. So the first step here is we have to define the DP table. You can clearly see the robo has to start from here, and we have to find the unique paths to reach the destination. And the first example that they have given in the question, that itself I have considered here. So rows we have 3 and 7. So here the robo starts from 0, 0, this one, right? So in this case it has to reach 2, 6, right? So this will be 0, 0, 1, 0, 2, 0. So this will be 2, 1, 2, 2. This will be 2, 6. This one, the last one. Robo has to reach. We have to find the unique paths for the robot to reach the finale destination from 0, 0 to 2, 6. Right. So the first step here is we have to define the DP table. So let's create a 2D DP table. Nothing but here in this case this one. DP of this one, 2D DP table, right? So here DP of ij, here this one we can consider this one as DP of I and j. It represents the number of ways to reach the cell I, j. So DP of ij represents the number of ways to reach the cell I, j. Just remember this thing. We are creating a DP table, 2D DP table, right? So the next step here is we are going with the base case, nothing but the first row and the first column, first row, first column, right? So let's start with the first row and first column. So here the first row, I'll just come here to this one. Yeah, here the first row, dp of 0 j, this one, the first row, right? So this one we can consider dp of 0 comma j will always be 1, or will always have one path, because robo has to move only right? So we are just considering the base case here, first row and first column. So the first row dp of 0 comma j will always have one path, because the robo can only move right. So when we consider first column, dp of I0, this one is nothing but row, first row, this is nothing but first column. So this will be always 1, and this will always be 1 as well, because the robo can move right and the robo can move left, I mean down. Yeah, this is the base case. So we can fill in this way, right? So this will be 1 1 1 1 1 1. So yeah, this one we can ignore. So this one we can just ignore these cells in the grid. We can just ignore these cells, right? I hope this is clear. So next step is to we have to fill the dp table, all the dp table. So here one thing we can observe here, each cell dp of ij can be reached here. Each cell uh, dp of ij, you can clearly see here, each cell dp of ij can be reached either from the top cell, right? dp of I minus 1 j, either from the top cell, dp of I minus 1 j, from the left cell as well, nothing but dp of I j minus 1, right? So we can just make use of the formula, this formula. We can just make use of this formula. dp of ij equals dp of I minus 1 j plus dp of I j minus 1. So just keep this one in mind. So we'll be making use of same formula to compute, right? Or to fill the dp table here. So this will be easy. dp of ij equals dp of I minus 1 j plus dp of I j minus 1. We'll be going with this formula basically. So initial tables we have here is 1 1 rows. We know this one, right, from the step 2. So here this will be 1. So when we go with this formula, you can just compute for every cell. I'll just write the solution directly here. This will be 3 4 5 6 7 3 6 10 15. Yeah, this one will be 21 28. I have already computed this one. So so I'm writing this one directly. So you can just go with this formula, dp of I minus 1 j plus dp of I j minus 1, right? So dp of 2 comma 6, nothing but this will be 2 comma 6, the last one for this particular example. Or we can just consider final or final cell, or the right bottom right cell, right? Final cell, this will be bottom right cell. So this one will be, in this case, 28. So you can clearly see here, this one, the value that we have got here is 28, right? So the final value at dp of 2 comma 6 is 28 here. So the answer would be quite obviously 28 here, right? So the final one, this one, I'm speaking of this one, the final cell, the final value of dp of 2 comma 6, nothing but the bottom right corner, you can clearly see here, this one is 28. So the answer will be 28. So the answer that we got here is 28, which matches the output that they have given, right? So the approach works absolutely correct in this case. So this is the approach that we will be going with. So 2D DP, right? So let's start writing the code now. So here let's start writing the code, right? The first step that we had discussed was we have to create the 2D DP table and initialize all the values to 1, if you remember, right? So that's what we are articulating that one in the form of code. Let me give here, let dp equals from let's set the length of length to m, this one here, right? So as this is 2D DP array, we have to go with m and n both. So this will be array of m and array of n. Let's fill this one with 1. Sorry, not n here, 1. So we have already discussed this one. So I hope this is clear. The second step here is we have to fill the DP table using the recurrence relation. So we went with the formula. So if you remember the formula, so I'll just make use of 2 for loops here. This will be let I equals 1, I less than m, I plus plus. So this is fine. Now let's iterate through the columns, right? For let j equals 1, j less than n, this one will be j plus plus. This is fine. So we are iterating through the rows and we are iterating through the columns. So here each cell is the sum of the cell above it and cell to the left. So this one formula we have already discussed. So again I'm telling here, these 2 for loops, the first one is we are iterating through the rows and the second one is we are iterating through the columns. So here whatever I'm writing, so this one is this is just the formula, means each cell is the sum of the cell above it and the cell to the left. So we already know this one. So I'll just give here dp of ij, this is equal to dp of I minus 1, this is j, plus dp of I, this is j minus 1. I hope this is completely clear. So the final step here is we have to return the value at the bottom right corner. So this will be m minus 1 and n minus 1, right? We have to return. This will be dp of m minus 1 and dp of n minus 1. I hope this is clear. Let me format the code once and let me hit the run button. So here you can clearly see the sample test cases are getting accepted, right? So let me hit the submit button. I hope this works. Let's see. Yeah, you can clearly see all the test cases are getting passed here, right? So the code works absolutely correct in this case. So let's quickly discuss the complexities of the code that we have written, right? So the approach that we went with here is dynamic programming. We know that one, right? What would be the time complexity here? The overall time complexity would be here because of m into n. So we fill the m into n grid once here. This is fine. What will be the space complexity here? The space complexity would be because of m into n as well. So we are storing the m into n dp table. You can clearly see here. So we are filling the m into n grid exactly once. So the time complexity here is because of m into n, and we are storing the m into n dp table. So the overall space complexity would be because of m into n as well, right? So overall time complexity and the space complexity here is because of m into n. So I hope the solution that we have written is entirely clear, right? For now, this is it. Thanks for watching, guys.